there's conceptions of this out there in sci-fi and otherwise that imagine this, where everyone's chasing their own dream, and they don't have to worry about how to feed themselves, and they know that if they work hard, they can have access to opportunities like going to Starfleet Academy or otherwise.
Okay, so really happy to welcome back on the show Trent McConaghy, co-founder of Ocean Protocol. Trent, it's been a while. How are you doing?
I'm well. Good to see you. Good to be on here again.
So obviously the podcast has been going for some time now, and I reckon I've known Trent since 2013, maybe. We did have you on the show as one of the first guests several years ago. Hopefully, we've grown the audience by now. We've got lots of new people that have come into the space. Wanted to reintroduce Trent. Ocean Protocol actually has a number of announcements, so we're going to talk through some of those and some new releases. But actually, I think it's a very timely moment to bring Trent back, because time has proven him right on his thesis about the convergence of blockchain and Web3 and AI. And actually, a number of the innovations he's brought to market, even prior to Ocean Protocol, all had their moment. He's been right more often than he's been wrong, at least that I'm aware of. Maybe he managed to hide the things he got wrong. Certainly the kind of more high-profile public ones, he's pretty much hit the nail on the head. And of course, I think by now, everybody's aware of perhaps some of the emerging problems, challenges of AI as it goes mainstream with its killer apps, but then also the potential possibility for Web3 to be able to fix some of those, potentially even extend the promise of what's possible with AI, how it's owned, and the data economy. So just very quickly, Trent is a serial entrepreneur that came to blockchains from the perspective of AI and machine learning, had multiple exits of AI companies to Synopsys and Siemens. As I mentioned, has kind of been ahead of his time with a number of initiatives, going back to Ascribe, which was kind of doing blockchain-based art. I guess we call it NFTs now, in 2013, BigChainDB, blockchain database, and then more recently, Ocean Protocol, which he co-founded with Bruce Pon. We were very lucky to be an early investor in that. I think technically in the friends and family round, after many beers in Berlin, usually talking about the convergence of blockchain and AI. I don't know how they rank in SEO terms, but certainly some of the earliest, deepest thinking on that subject, Trent was doing, albeit without the level of attention I think that it deserved. I think that's kind of coming now. I think Ocean Protocol's time has also come, which is great to see, and well done for hanging in there, being able to kind of finance, continue developing that product across cycles, basically. Trent has also pioneered token engineering as a discipline. So going beyond token design and actually bringing engineering principles, something we've continued to collaborate on. And then also looking at data tokens. I think we call them IDOs. IDOs also have a different meaning now in terms of launching tokens on DEXs. But I think we're the first one to use the term IDO in terms of initial data offering. And then we're going to talk about Predictor, which is the new thing. So we've got a lot to cover. As interested as I am in Predictor, I do think that we need to do you service and allow you time to kind of reflect, I guess, on all those things that you've got right. And I think for founders, hear your founder journey of being early. Timing's obviously one of the hardest things to get right as a founder and investor. But if you are perhaps too early sometimes, surviving is the next best thing. So it would be great to kind of have you give a potted history of what got you to here, I guess, Trent, reflections on some of your early thinking on blockchain and AI, and then, of course, we'll get into Predictor.
I was raised on a pig farm in the middle of Canada, studied electrical engineering and computer science, and for fun, I was always hacking, on the side. During undergraduate, I was hacking on AI, et cetera. I managed to get some summer jobs where people would pay me to work on AI, which I couldn't believe at the time. This was the mid-late 90s. So from that, it led me straight out of undergrad to start my first company, which was AI for designing computer chips, specifically for creative design of analog circuits. Initially, we were doing things like using genetic programming to evolve the circuit topology, the structure. Turns out that was too early for the market, so we had to do a zoom-in pivot and focus on just optimizing parameters. That was enough. That was sufficiently advanced for the users at the time. And, these days we hear a lot about AI for creative design and all that. It's gone mainstream. Back then, we were basically having to do all this heavy lifting, designers seeing what we had and thinking, okay, if this computer is doing the creative design, what am I doing? Is this thing going to take my job and stuff? So we had to basically, teach them that it was more like a co-pilot in terms of the, phrasing used now. I think that the product was called Genius, Unleash Your Genius, right? That was the phrase. For the first company. Started that company officially in 1999 based on about a year of prototyping and hacking before that. And then, this was the height of the dot-com bubble. So we were a bunch of kids basically straight out of undergrad. We managed to raise a decent amount of money from Silicon Valley and elsewhere. And then, grew the company, built it up, went through our pivots, went through a cash crunch because we were a bit early. So this is where we did the zoom in pivot and we found a way to hang on. And then eventually, we started getting real customers, real traction, and the company got acquired in 2004. So, a lot of events happening in that 5-year period. And it was, a really great first adventure in the world of startups. From that, I decided to do a PhD also for creative AI, focusing on circuit design because I felt like that I hadn't fully cracked that problem for the first startup. And, by going into academia on that, you don't have to have be constrained by commercial needs and stuff. So I went full force and I came up with something that I was quite proud of, where it drew on a lot of the corpus of engineering knowledge for designing circuits. So it would actually be able to basically think of it like you could draw any random circuit from this well-defined distribution of random circuits, and they would all be well-formed. They were correct by construction. And that was sort of via this language of circuits, if you will. Just sort of like now, if an AI comes up with something, usually it's pretty well-formed for an image, say. It looks pretty good. It's, that in its case, it's sort of a lot of training data, but it gives it pretty good constraints in what it comes up with compared to, AI coming up with images 15 years ago tended to be a lot more janky than it was good. So anyway, that was the approach I had for the PhD. At the same time as starting the PhD, I started a second company, which was also AI for chip design. In this case, it was for verifying analog circuits and memory circuits and so on. For example, does a memory bit cell, does that whole, which stores a bit of information, 1 bit. So, a 1 gigabit memory chip would hold 1 billion of those bit cells, plus some error correction, et cetera, sense amps, et cetera. So it means, though, that each bit cell, has to have a very low failure rate, on the order of 1 in a billion. But it's a huge difference in the failure rate if it's 1 in a billion versus 1.1 in a billion failure rate. So how do you estimate that? You could go and do 50 billion Monte Carlo samples, which means 50 billion simulations, but that would break the bank computationally. So we had to figure out tricks to chop that down where we could get the accuracy as if we did 50 billion simulations, but do it much faster. So, instead of having to run a cluster of 1,000 machines for a month, we managed to chop it down to about 10 minutes on a laptop or so. So we were pretty happy with that. That was the second company. So the first company was really focused on design of analog circuits. The second company was verification of analog circuits. And in the world of CAD for chip design, those are really the two big pieces, the two big subfields. There's design and verification for digital and for analog. And as a quick aside, I just gave a talk at ETC, sort of teaching the token engineering community about how the circuit community approaches verification of analog circuits, which is actually very, very similar. And then said, hey, what was done in the world of verification of analog circuits? If we say that a lot of the problems we're seeing right now in token land, such as, flash loan attacks, breaking contracts, and a lot of bridge attacks and otherwise, these really are the problem of analog token verification. So it's not the digital side of the smart contracts. It's the analog side. It's the incentives. It's, the non-on or off, not true or false, but really the continuous value behavior and continuous in time behavior. So if we actually take the theory, practice, and tools from analog circuit verification, bring that into the world of analog token verification, there's some pretty cool wins there. So I'm hopeful for that. It seems that the field is getting there and we keep maturing. And it's really been awesome, by the way, to iterate with Outlier on this too. In fact, even at that talk, the speaker right before me, Achim, is from Outlier. So it was nice to be back to back with him. So I'll just pause there for a second before I get into the blockchain stuff and see if you have thoughts or comments.
So it's really interesting. Again, you really informed my thinking around token design, bringing engineering rigor, the idea that if we want these systems to be able to handle the economic load of billions, trillions of dollars worth of value transactions, then we need to be sure they're going to hold up as much as we need to be sure an airplane flies or a bridge can, take that traffic. And so I think, taking that learning from engineering and modeling, designing complex systems, as you say, with incredibly low failure rates, really opened my eyes to the importance of token design. Obviously, something we kind of continue to invest in thinking about here at Outlier. I'm glad we got to talk about that. And I think one of the interesting things, maybe in retrospect, maybe it wasn't by design, but in retrospect, if I look at your career, it seems that you work in one domain, maybe working on something, quite specific that leads you to another problem, to identify another problem, which then leads you on to your next startup. And there's kind of almost this chain, which seems to be quite logical in a way, of startups that naturally kind of feed into one another as a narrative, all the way to Ocean Protocol. It would be good to just touch a little bit on Ascribe, because I think that was when I first met you. And again, I think a project well ahead of its time. One of the really cool things that I've always loved about Trent is his commitment to open source. So, practically everything that's ever been done, as far as I'm aware, in the Web3 space has been open sourced or eventually open sourced. When there might be a particular initiative that might commercially have not taken off, that code base has really helped kind of inform a lot of other innovation going on in Web3. But yeah, it'd be great to talk about Ascribe, and then I guess BigChain DB as a stepping stone into Ocean Protocol.
Yeah, basically, to wrap up this verification, so the second company, the first company was called ADA, by the way, Analog Design Automation. The second company was called Toledo, the verification one. By about 2010, 2011, we had built everything that I'd set out to build. We had become profitable. We had won most of the big semis in the space, the Qualcomms and Samsungs of the world. And TSMC, which was kind of one of my main goals at the beginning, was if we can get TSMC using this, it means that they're using AI to drive Moore's Law, which is always just sort of, as a nerd, it's a very fun thing to sort of aim for. And I was happily surprised to find TSMC engineers using our software to design the next generation of silicon when I visited them in about 2011 or so. So with Toledo, we had got to the point where we had turned into a scale up. We were past startup. We had gone through harrowing times too. There was cash crunch at one point too. And then, we were in a scale up mode, and I started basically thinking about other things that I might be interested to do. Like you had mentioned, right? It seems that, the dots connect quite logically. Myself, I'm a big nerd, right? I love to follow lots of fields, AI and VR and crypto, and BCI, brain-computer interfaces, and more. At the same time, I recognize that, I have a particular set of expertise that it's wise if I'm going to go jump into something else to be able to leverage my existing expertise and then learn what I need. And that's in line with a lot of career advice that people have given, right? You want to do something that can pay the bills, ideally well, something that you're passionate about, and something that you're, hopefully good at, right? So that intersection of those three things: money, passion, skill. Anyway, that's part of the thread too. And then, I was always super passionate about AI. Semiconductors was always interesting because it was a hard problem that was applied and could have a big impact. To be honest, I never paid close attention to cryptography, but, I was quite interested in the cypherpunk stuff happening in the late 90s. And then when Bitcoin came out, my friends and I would hang out talking about it all the time, right? It was super exciting to us. And we only got the Bitcoin financial stuff. But then in 2013, I landed in Berlin and started hanging out at Room 77 with a bunch of the people there talking about Bitcoin. And they were already talking about blockchain. And I'm like, I never thought about this that much. So I went back to the Satoshi white paper, reread it, thought about it a lot, and realized, wow, we've got this general purpose technology. It's as powerful as AI or BCI or these other things. It was sort of an arbitrage. Most things you've seen coming for decades, right? AI, people have been talking about since the 40s or 50s, depends who you ask. And same thing with, say, high temperature superconductivity, right, which we just saw emerge as a final technology. Blockchain, as sort of this decentralized ledger, it wasn't part of this mainstream discussion. People had anticipated it here and there. Probably most famously, the Agoric papers from the 80s with Mark Miller and others. And then also, some of the early writings leading to the web, things like Xanadu, Ted Nelson, and so on, which also affected Ascribe, of course. But the point is, this wasn't part of the mainstream discussion the way that AI was in some way. I learned about Bitcoin, got excited about it. 2013, I learned about blockchain, got excited about it, and realized there was even, different than AI or other things, there was also an arbitrage, which is a useful thing, which is realizing that this thing could impact things and most of the world didn't get it yet. To me, extra interesting as an entrepreneur because it buys you a bit of time to chase new ideas, and it's even more blue ocean, if you will, right? Rather than, the Red Sea of Shark, it's blue ocean. So I thinking about different ideas, and my wife, Masha, she is a professional museologist. She is trained at the École du Louvre, the Louvre School for Museology. She has a PhD in the relationship between art and commerce from the Sorbonne. She had worked at galleries, including in Paris and in Vancouver, contemporary art, traditional art. She had also helped to assistant curate at the Louvre. So she had this very deep art background, right? Whenever we were in whatever cities we were in, Vancouver, Berlin, whatever, she would be spending a lot of time in the art scene, hanging with artists, etc. So with that, when we arrived in Berlin, she started to notice this problem around how do you collect digital art? A collector came to her and said, I just bought this DVD for $10,000 from your gallery with this art. There's a scratch. Can you replace it, please? And the artist is like, well, no, I sold you the artifact. I didn't sell you the thing. So the collector was kind of like, okay, that's not like, both sides were angry with each other, right? Because there was this confusion about what it was that was bought. But it was actually really hard for collectors to buy digital art. They would actually have to buy some artifact. If you're buying digital art in the 80s or 90s or 2000s, you're probably buying some TV with it or DVD or something, right? Yet at the same time, we were well into the web era, more than 20 years worth of web already. Yet it was really hard to monetize that because, things could be copied and pasted. So it was hard for collectors to collect the art. And because of that, it was hard for digital artists creating digital art to make any real money from it. So that was a big question. It was emerging as a big problem. The art world had called it an elephant in the room problem. One day, Mash and I were hanging out after going to some gallery, and she was talking about this elephant in the room problem. How do you collect digital art? And I'd been going on and on about blockchain. And this is a common thing. We're both quite patient and interested in what each other have to say. And then we both sort of looked at each other as like, wait a minute, what we just asked together, what if you could own digital art the way you own Bitcoin? And that turned out to be a wonderful question to ask. And we pulled on the thread and pulled on it. And, we're still pulling it 10 years later.
But just for context, what year was this then? Ascribe was 13?
Yeah, this was probably maybe May of 2013 when we asked this question. And we started, writing, pursuing it shortly after, like June, July. We actually filed a patent for it, I think it got filed officially in August of 2013. We let that expire because we realized this wasn't in line with the Web3 ethos. At the time, we were coming from the world of enterprise. But we let it lapse simply because of that. We didn't want it to get in the way of actual innovation. So by 2014, we were iterating on a beta with many artists. And we went live in, I think, January 2015. And what it was basically was, these days, you would call it an NFT platform. It was on Bitcoin. Ethereum didn't exist yet. You could, someone could come along, sign up with their email address and just a regular password. Under the hood, it would automatically compute a private key that for Bitcoin, HD private key. It would get registered on the Bitcoin blockchain following a particular protocol we just devised called Spool Protocol. Secure public ownership layer. I'm missing an O, but something like that. And then you could also transfer it, right? So once you've registered it, claiming that you have the copyright to it, then you can transfer it, which basically works as a sublicense. And we actually had a lawyer working with us for better part of 2 years, where he devised all the legals around this too. So you not only had technology protection via blockchain, you also had legal protection where you were claiming copyright, and then it was the licensing, sub-licensing, et cetera. So, it's best of both worlds. You've got the traditional world of legals and all the backing that nations give for that, as well as the technology-based protection. And we, built that up, grew it, got to about 10,000 artists and users, 40,000 registered works. Went to raise money for the Series A. Our numbers weren't good enough for Web 2. That was the metric at the time. So we basically said we have to pivot. We did some experiments, led us to BigchainDB, decentralized database. That was really targeted, for enterprises. That went well for a while. We did a lot of POCs, I think like 50 POCs with basically every big name in Europe. And none of them went to production. Just enterprises weren't ready for production blockchain. And, this is 2015, 2016. So we said, let's go back to permissionless. We prefer that anyway. And I was missing AI. I was starting to think a lot more about AI. You hinted at that already, and I can talk more about that. So by mid-2016, I was starting to write about how AI and blockchain intersect, articles on AI DAOs and how blockchain can help AI, et cetera. And all roads pointed to decentralized data markets. And we realized this would be a really, great nut to crack, problem to solve. And that's what became the inception of Ocean. And we spent the better part of 2017, getting Ocean going, and then been at it ever since.
Yeah, and we're going to get into Ocean Protocol in a little bit. One thing I want to go back to, sorry to jump around a little bit, but I think it's an interesting concept for founders, perhaps especially now, right? There's a big capital crunch in the venture world. There's not enough venture capital going around for early stage founders. You mentioned the zoom in pivot. Could you just elaborate on that a little bit?
I'll even give an example. So PayPal started out quite broad. It was basically, payments over the internet. And they didn't have, they had a pretty broad set of customers, helping people buy on any website that, any shop that people set up, whether it be PayPal or the Amazons of the world or otherwise. As they iterated, they discovered that something like 80% of the traffic was actually on eBay, used goods and collectibles and stuff, right? And that was a big site in the internet in the early 2000s, right? So they decided to double down on that and basically do a zoom in pivot where they focused the vast majority of their effort to having a really awesome experience for eBay. And because of that, the eBay experience got better more quickly than the rest, and they grew much better. So my first company, we started off with quite a broad scope, basically doing search through the space of possible circuits, like analog circuit structures and parameters. So like, how does this resistor connect to this transistor, connect to this resistor, and what is the resistance of this, and what is the width of that transistor, et cetera. But this was, too broad. So in our case, the zoom in pivot was simply a more narrow search space. Having a fixed topology where you're not changing the structure, we would just wiggle the parameters. So it's just doing optimization, not synthesis in the parlance of that. So zoom and pivot is basically taking your product offering, focusing on just one aspect of it. And in our case, we stopped shipping the rest. We just focused on the optimizer because it allowed us to do that. In the case of PayPal, they kept shipping the rest, but they really focused all their energies to make the eBay experience really awesome. So that's the zoom in pivot. There's many types of pivots, right? You can just go from one product offering to the next. My next company, also, we had to do a pivot. We started off with doing optimization for analog circuits, but accounting for yield, like statistical variation. But it turned out that was also too far ahead of its time. So we chopped that down to just statistical analysis. But that turned out not to be compelling enough to compare to the offerings out there. So then we added in high sigma statistical analysis, which turned out to be compelling because it was a big savings in compute time and so on. So we basically did two pivots until we had our first hit product in that second company. And even in this third project, if you will, in blockchain, right, it all derives from the same company. It was initially ascribed GmbH. And then we did a pretty big pivot within crypto land to decentralized database, Big Chain DB, think like MongoDB, but with Tendermint consensus around it. And from that, we did another pivot to Ocean. But, crypto was so new that you could go from, one offering to another and, manage to reuse a lot of the skills that you had built up. It's been pretty blue ocean because there's just so much to build. So we were able to go from one thing to the next, the broad brushstrokes. And even within Ocean, right, we've done various tunings over the years too, various sort of smaller pivots, if you will, towards traction.
Yeah, and I guess as you said earlier, considering much of what we were talking about was pre or just post Ethereum launch, in a way, certainly how we looked at the space as an investor, and at that time we would have really framed ourselves as an incubator, not an accelerator, that it was really deep tech. The expectation is that anything you invest, well, firstly, there's no point investing in anything that wasn't infrastructure. Quick realization for us. And then secondly, you would have to expect that to take several years before that thing would even be used. And so that timing thing was so critical. But I think that mindset meant there was a lot more latitude for experimentation. I think the patience for that's worn out now, right? We're a decade into crypto. People want to see adoption. They want to understand cost per acquisition for users. The world's moved on. I don't think big infrastructure projects will get financed that much anymore, right? But it's interesting for people entering a new domain, that kind of opportunity space that's afforded to a founder. So then let's get into Ocean. So the kind of problem statement that kind of triggered Ocean Protocol. And then I guess the stack and innovations and how that's evolved. What are we now? So that's 17, 3, 6 years. Yeah.
Yeah. So I'll talk about Ocean evolution, et cetera. But I want to loop back just on what you're saying here. I think it's useful for your audience on, building infrastructure versus last mile apps, et cetera. There's a challenge here. Anytime you're building infrastructure, it means that it's going to be a longer time to actually get traction where there's dollars, in a sense, because the traction comes from the last mile app. So you sort of have to have infrastructure and some sort of last mile usage, probably, right? So that extends the timeline. And also, if you're kind of visionary, trying to build something, you have 1 or 2 pivots. It takes time, but the big challenge is cash. And cash is king in a startup, but most startups maybe have the luxury of one big pivot. In my first startup, we had one big pivot. In my second startup, we had small to medium-sized pivots, right? With Ascribe, Big Chain Ocean, we've had 2 big pivots, right? So in all of those, though, it was pretty harrowing times, right? Going through the pivots. And I've looking backwards, I realized this, that I kind of had this mantra to myself, but it was subconscious for years, which is, I'm never going to let this thing die. I'm going to make it happen. I'm going to make it happen. I don't care what's going to happen. Even if everyone else leaves, I'm going to do it myself. And, I'm a builder, so that I know that I probably could, even though it'd be slow and stuff. It'd be slow and maybe painful and stuff. But if I can find a way to feed myself and keep going, then, other people can join the cause and so on, right? So fortunately, it never ever came to that. But having that resolve, that it's like, I'm going to make this happen no matter what, actually makes it easier for other people to join in a sense. You shouldn't always do that, by the way. I have, my wife, in a sense, as my safety valve of like, Trent, you're crazy. If I was, being a lone wolf for 4 years on something, it's probably time to change. But there's value in that, right? And there is really cool, my favorite example of this in startup land is Blogger. So Ev Williams had started Blogger just by building this thing for himself on the side. It was the first, good blogging site. Built it up. It was starting to get traction, and some VCs came around, and he took some VC money and he grew the team to, I don't remember, 10 people, 30 people. So they built it out. But then there came a cash crunch. I think it was the dot-com implosion or something. I forget exactly which one. They hadn't gotten good enough traction making enough money to be able to pay for them. So basically everyone left except for Ev. So once again, he was lone wolf, I think, coding for at least a couple of years on his own. But the traction kept growing. I believe that's when he got acquired. I forget, Yahoo or Twitter or someone. He got acquired based on just having lots of traction. And so the point is, he slogged it out. He was able to do it. Having this resolve, he knew he was onto something. And he had the resolve and the skills to just make it happen, right? So I think that's a useful heuristic, but you should never be, sort of 100% absolute in everything. I always give yourself sort of maybe one, a backup and a backup plan if you need. But that definitely helped. In the first company, we actually shocked our investors. It wasn't just me with this resolve. All the founders were like this, and all of our, earliest employees, et cetera. We were all like this, and we found ways to extend our runway. That was, I look back, it's like, holy cow, that was pretty cool what we pulled off.
Yeah, and I think this is why it's important for us anyway, that there's always a technical co-founder. The technical team aren't just contractors. They're not just employees who will come and go naturally when the uncertainty increases or the risk increases. But you're absolutely right. At some point, sometimes you have to say, okay, I might be right, but I'm too early, or whatever other reason why it might not make sense to kind of pursue with that path. And look, I think that's really useful stuff. Thanks for that in terms of pivoting and kind of navigating that space. So let's then go to kind of the problem statement as was for Ocean Protocol. Maybe it's the same, maybe it's a slight tweak, but as it was in 2017?
In 2016, I wrote this blog post, Blockchains for Artificial Intelligence. And by that time, I'd come up with this heuristic, this set of tools to identify how blockchain can help any field. I broke it down to 4 specific benefits: decentralized, immutable, assets, and incentives. So decentralized as in you can have play coordination games to coordinate a group of people, whether it's 10 people or 100 or 10,000. Bitcoin is 10,000, multi-sig is 10, and DAOs are somewhere in between. And, if it's 10,000, it really becomes sort of a utility across the internet. So that's decentralization. Immutable means provenance, provenance of data, asset trails, provenance of money, provenance of art, all of that. Asset means not your key, not your Bitcoin, not your key, not your data. You own it. if you have the key to it. So this is, the bearer asset approach rather than someone else having some say in what you own, right? And that's very useful because that's become the standard. That is the standard in blockchain land, and it's very healthy and helpful. And then the fourth one that I actually only really fully recognized in 2017 is incentives. And I think that's actually the superpower of blockchains. That this idea that you can get people to do stuff by paying them in tokens. And then the question is, what do you want them to do? And how do you go about designing a system to get them to do this? And that looks a lot like an optimization problem. You basically come up with an objective function and a design space. And the objective function is, something that you want to maximize or minimize. So Bitcoin says, I want to maximize the security of Bitcoin. How? I want people to go and contribute to the security by doing hashes in this particular way, right? So that's the overall set of tools that I came up with. The first three in, I think, 2015 or 2016, and then the fourth one in 2017. Anyway, I applied this to, and I'll summarize once again, decentralized, immutable, assets, incentives. So with that tool, I turned the crank in late 2016 and said, what does this look like for AI? And by the way, what does this look like for big data? I found, for each, I just said, okay, how can decentralization really help AI, right? And you can have things like shared ownership of AI algorithms, shared ownership of data feeding into AI, public utility networks that are fully decentralized with training AIs and otherwise, right? And turned the crank and went through all of this. That blog post, did turn out to be quite popular too. There was this recurring theme of data throughout that because, data is unreasonably effective. If you want to, make your AI more accurate, you have a choice. You could spend 4 years worth of PhD level research to improve the accuracy, to reduce the error from say 20% to 10% or 10% to 1%. Or you can take an engineering approach and throw 10x more data at it. And you'll get similar, like roughly the same results, which by the way is a bit embarrassing to AI people because, AI people like to be able to, be the smartest people in the room and stuff with their algorithms. But now you can just have more, more data or more compute. And if you have more data, of course, you need more compute. So, and it can be 10x, then 100x, and 1,000x more data. Google started doing this in earnest in the mid-2000s, followed by all the other big guys, right? Given that the vast importance of AI to data, I wrote about that also in that article and realized that there was these big problems. The Googles of the world had reams and reams of data, but what about the average AI researcher trying to, predict, come up with models that could predict cancer? Try to detect early stage cancer. And I remember one friend of mine, he was working with a hospital and he got access to a data set. It's so bad, it barely deserves the name. I think it was like something like 120 people. And it was DNA data, like SNP stuff with something like 100,000 dimensions per data set, per point. So you've got 100,000 dimensions and like 100 data points. It's really, really a poorly formed data set. You can barely do anything with it, right? You can apply regularized linear learning, but in the end, it's really hard to do much, right? But imagine that same dimension of problem with 100,000 vectors, but you've got 100 million data points, or a billion, or 10 billion. That starts to get really interesting, right? And that's actually what we've been seeing with AI for the last 20 years, but it's really hit the mainstream especially the last couple of years where we see these, large language models or very large language models, right? In circuit land, we used to have large scale integrated circuits, LSI, and then those got really big. So we started calling them VLSI. I think that was the early 80s, VLSI. And then they got extra super large, but they didn't come up with more acronyms. They just kept calling them VLSI all the way along. So I guess we smartened up in neural network land. We just called them large language models, but we'll probably never see VLLMs.
Just to pause on that point. So obviously by now everyone's heard of OpenAI. They probably use ChatGPT, and it's now being reported that there's these diminishing returns. In fact, in some ways, the more it's being used, the stupider it's getting, or the worse the answers. Could you maybe give perspective on that? Right? Was that an obvious thing that was going to happen, or is that something that's emergent?
Yeah. So actually, about 2 or 3 years ago, someone actually did a very cool study. Actually, several teams, but there's a paper that is sort of the scaling law for AI for LLMs, where if you want to have a particular error with a particular problem domain within language, then here's the size of the AI model you need. Here's the size of the data set you need, right? And if you have 10x more data, it won't move the needle. There really is a sweet spot. But it allowed researchers to really calibrate how much data they might need for a certain sub-problem they're aiming for, right? And that was actually, like a medium-sized breakthrough a couple of years ago. What we saw, OpenAI, if you recall, a couple of years ago, they raised, $10 billion from Microsoft, or was it $1 billion? A lot, I think 10, right? Because then they went and spent most of that on cloud services, right? I mean, if you've got $10 billion, you're not, using that to hire, 10,000 employees immediately, right? So they had relatively small number of employees still, but it was spending most of that on compute. So training GPT-4, which powers ChatGPT, et cetera, was probably, I don't know if it's reported, but at least $1 billion worth of compute, I'm pretty sure, right? So the thing is, that was for GPT-4, but maybe now they want to do GPT-5. They're working on it. They've been working on it for a while, of course. If they had to spend $1 billion worth of compute and maybe another $1 billion to gathering data, so $2 billion, GPT-4, then for V5, maybe they want to go 10x. Now you're looking at spending $20 billion, and it just doesn't fly, right? It's too much. So they hit a wall, actually more economics than parameters. And maybe they were seeing diminishing returns, but the thing is, it's just not worth spending $20 billion to find out yes or no, right? It was worth spending $1 billion to find out, which is interesting. And by the way, this is actually what happened to Moore's Law itself too, right? When Intel, did the first fabs in the 60s, it would cost, $10,000, $20,000 to do that initial fab to manufacture computer chips, right? Like VLSI circuits, or back then extra small integrated circuits. But then, with each passing generation, the price would go up in some exponential factor. And roughly speaking, at least from the 80s onwards, it was roughly doubling, right? So, a fab might have been 100K, and then the next generation was 200K, then 400K, then 1.6 million, et cetera. And by the time of about 2005, it would have been about $1 billion, if I recall correctly, to do a fab, right? Maybe even by then, 5 billion. It was a lot, right? And then within that fab, that's just the factory with all the machines inside. And then to manufacture a given chip, which is basically come up with a set of instructions, it's called a mask set, would cost $50 million, right? So you better get this right? That's why we have all this really awesome circuit verification stuff. So $50 million for that, plus the fab, that's $2 billion. So what happened was, up till that point, up until about the year 2000, there was tons of semiconductor companies which owned their own fab, right? Everyone and their dog had their own fab. Texas Instruments and everyone, right? Not just Intel and Samsung, but Sony and the rest. Fast forward to about, from about 1997-ish till about 2005, they all got rid of their fabs. There was basically just a handful left. There was a pure play fab that had emerged called TSMC, Taiwan Semiconductor Manufacturing. There was Intel, because they were so huge. They won big in the 90s, right, with Wintel, Windows plus Intel, and Samsung, and basically everyone else. Texas Instruments sold their fab, Sony sold their fab, et cetera. They all went fabless. And then there was a bunch of new startups that just started fabless, like Qualcomm, right? So basically, the economics dictated it. And then over the years, even these guys have dropped off. So in the last couple of years, maybe I think 2 years ago, 3 years ago, Intel even started using TSMC for the most advanced process nodes, just because it was too expensive otherwise, right? $10 billion, $20 billion or more for a new fab. We're seeing exactly the same thing happen in LLM land. So Moore's Law slowed down and then is basically kind of ground to a halt because of economics. And this is the challenge we're seeing right now with LLMs. But with circuits, there is research to try to find ways to do the cheaper, but people aren't as used to it there because for the last, 40 years, it's been this gift that's been keep on giving, actually 60 years, right? It's kind of amazing. In LLM land, because everything is open source and there's huge financial incentive to do a good job, since GPT-4 came out and even before, there's researchers that keep finding ways to get a 2x here, a 10x there, a 2x here, a 10x there. These days now, people are getting to the level of GPT 3.5 level models on a single NVIDIA GPU, which is kind of amazing, right? On just say 1 day to 1 week of compute processing, right? It's kind of amazing. So that means that then if you're OpenAI, maybe you can use that. You still run 10 of these or 1,000 of these for a month and you see what you come up with. We've sort of paused by just doing the naive 10x, by spending 10x more money, because we had this economic constraint. And instead, the open source world stepped in, plus OpenAI, but especially the open source world, the stability AIs and the llamas and all this, and made everything way, way, way cheaper, which is, and now everyone's building on that and just racing ahead, right? So AI is going to keep advancing, and I don't think we've hit a wall, right? There's so many people out there chasing it, and the economic gains can be so great that I actually don't see a wall. And a lot of the time, just as another sort of factor for this, every few years, there's some famous AI researcher that comes along and says, I don't think AI can go any further. We need to have fancy thing X, fancy thing Y. We need to do symbolic modeling. We need to do expert systems again. We need to do this. But in the end, it's just more compute, right? One of my favorite results was the state of the art in, say, 2015 was, even then they were calling them deep neural networks, right? It went from deep belief networks to deep neural networks from the likes of Hinton and stuff out of Toronto. And this Schmidhuber and his team out of Switzerland and / Germany, they took the same neural network architecture and training algorithm from 1989, the plain Jane backprop, and they just took it, they made it larger. Instead of just 3 or 4 layers, they made it 10 or 20 layers, and they just threw a ton of compute at it, and they got the same results as all the deep learning stuff. So it was not any change to algorithms at all or anything, and it was just like lots of compute. Not really any more compute per se compared to the state of the art. But that was also kind of, once again, this thing that you didn't need to get fancy with algorithms, et cetera. And by the way, the Hinton and all the deep belief stuff was not that much changes anyway, right? It was a tweak here and a tweak there, really, if we want to be honest with ourselves. And, since that time, we've had a couple other slightly bigger changes. We've had transformers changes and the fine-tuning, people going nuts on that. But all in all, it hasn't been massive changes to these basic ideas of neural networks, 1989 and nonlinear perceptrons of the early 60s. So my point is here, it's still a very blue ocean. It's a broad set of design space that people are exploring, like thousands, probably tens of thousands of people exploring aggressively. Some of them will pop. So we're not going to hit a wall.
And so does this then take us full circle back to the data problem or the data opportunity, right? So obviously, or my understanding anyway, is that OpenAI, ChatGPT and GPT-3, etc., have been primarily trained on open web data, which in theory anybody can access. Of course, there's various claims to whether they should or shouldn't have used that for commercial purposes, or Getty Images, suing various new entities for training on their prop assets, I guess. But effectively, that could only take you so far. Perhaps at a more generalized level. But as you then need to have deeper specialisms, you then need to access new data. So you need a new economic paradigm which incentivizes and enables that data economy. And I guess brings us back to the premise of Ocean Protocol, right?
After writing this paper about how blockchains can help AI, we saw this challenge overall. It was if you weren't a Google or a Facebook of the world, it's really hard to get your hands on really good data sets, large data sets to have accurate enough models. So how do you, right? And on the flip side, there was all this, tons and tons of data inside enterprises, for example, that could be used, for a price, but you have to address the privacy concerns. And then also there's all this data that individuals have on their smartphones, et cetera. It'd be awesome to be able to access that for a price. But in that case, also, how do you handle the privacy aspects there? And from the enterprises, too, they have to handle the privacy and the liability and stuff, too. So these are the big challenges. How do you sort of connect the potential data suppliers with the potential data consumers in a way that addresses privacy, in a way that you can have it where it's price data or free data, ideally having some form of price discovery, and ideally that there's no centralized middleman that ends up winning it all, right? That's already been a problem with the Googles of the world. But as we go forward, especially when we get into things like BCI data, neural data, you really don't want that to be controlled by Google. And Google seen pushback, right? They were trying to do federated learning across dozens of hospitals in the UK, and the UK kicked them out because of privacy concerns, right? It was just too much control of users' health data on that one thing. So you really need to have more decentralized management of this. So that led to Ocean basically saying, okay, at the heart of it, the heart of the problem is we want to kickstart this data economy. Maybe a way to summarize is level the playing field around data and AI. So make it where it doesn't matter if you're a researcher at Google or an undergrad student trying to build an AI model. You have an equal opportunity to access the data, and then on the flip side, level the opportunity to be selling the data, right? An open marketplace to be selling the data or sharing it, right? And as needed, where needed, you have provenance of where the data came from, right? And the provenance, of course, comes pretty easily with blockchain to track it, just like we did in a Scribe base with digital art, where provenance is king in the art world. That was the premise we began with Ocean, and it's largely held to this day. To be able to do the decentralized data marketplace, we kind of implicitly knew, but we really made it explicit very quickly, which was you need to have really good decentralized access control. So think like when you're using Google Drive right now to share something to someone else, you give their email, etc. And you're clicking share to an email address, whatever. There's this middleman in between called Google. Even if the data itself maybe is doesn't necessarily why do you have to have it living on Google Drive, etc. So ideally, it's living on Filecoin or Arweave or something decentralized, ideally encrypted, etc. You share to the person, and that sharing infrastructure is all decentralized too. And then if you want to make it really interoperable, why not make it where you can make it easy to manage and share the data the same way that you manage and share Bitcoin and ETH and 1,000 other ERC20 tokens and NFTs. So that means tokenizing it, right? So that's basically what we ended up building. The heart of it is decentralized access control, where if you hold 1.0 data tokens, ERC20 data tokens for a given data set, data service, then it means you can access the thing. You have you can come in and say, I want to start consuming this, and then you get the file or you get the access to the REST API or otherwise. That's the heart of it. And then Ocean has infrastructure to publish these things and consume them. And we have, typically it's, static data or REST API, but we also have this thing, compute to data. So you can actually have a script that runs next to the data itself, inside an enterprise's infrastructure or a hospital's infrastructure or on someone's phone that maybe computes the average across the data set or some other statistic, or maybe, does a bit of training to update some neural network model or something. So that's the heart of Ocean. If you go to, the apps on top of it, we have this reference app, the Ocean Marketplace, Ocean Market. And then there's a bunch of people building other apps. There's a decentralized Kaggle competitions called D-Sites. There's other data marketplaces that people have built. Probably the most famous one is Daimler has a spin-off called Accentric, where it's starting with automotive data, but they're also targeting other enterprises. So they've done all the things for enterprise compliance, things like making KYC really easy, KYC AML, identity related, and a bunch of other needs, and really doubling down on the computed data side too to handle privacy and liability, making it really easy for enterprises to adopt. So that's where we're at with Ocean. And I guess one other thing, we kind of just wrapped up, call it phase 1 of Ocean, and we're entering phase 2 sort of in the last year. Phase 1 was basically building to the white paper, everything we dreamed to build, et cetera. Keeping our promises to the community, which is, decentralized data infrastructure, data markets, all of that. And then the second phase that we're entering now is really going for traction, right? Getting off of the version treadmill and instead focusing on how can we really make this data economy happen? How can we, drive the data consume volume, the amount of money flowing through this open data economy where people have their own, choice of how to share privately, et cetera, and just grow that, right? And with that, the core team spends time working with other teams, maintaining the core stack, tuning it as needed, as well as, like hinted at in the beginning of this podcast, we have an internal effort around something called Predictor, which, as of this podcast coming out, we've just announced, and I'll get to that.
So let's get into Predictor.
Predictor is a stack and an application for prediction feeds. Its main users are DeFi traders and data scientists. So if you're a DeFi trader, you can go to predictor.ai. It's 2 O's, so PREDICTOOR.ai, predictor.ai. And you'll see there that it lists the top 10 pairs. So, or top 10 tokens by market cap, Bitcoin, ETH, etc. And for each of them, well, for Bitcoin, you'll see that it's actually giving a prediction of whether Bitcoin will go up or down 5 minutes from now with a confidence level. And it keeps updating every 5 minutes. And then below that, you'll see one for ETH and XRP and other things. And those, it won't say whether it's going up or down yet. You'll see a little buy button that you can basically choose to buy that feed. And when you buy that feed, then you get access to it for the next 24 hours. So basically what you can do then is you can have one window open where you're seeing the predictions of whether this thing goes up or down 5 minutes from now. And then you can have your Binance open. And this is actually focusing in the initial product on Binance pairs, Bitcoin True USD, simply because that has zero fees, and ETH, True USD, etc. So keep your Binance open, and if you think it goes up and you're confident in it, great. Buy if you want, or short, however you want, or do whatever other actions you want, right? So that's the experience from perspective of a trader. But of course, it's every 5 minutes, so why not wire it up with a bot? So of course, we make it really easy. We've got READMEs where people can fork a repo for running a trading bot in Python, and then change it as they need with just the predictions as they're coming. And then they can buy and sell as they need, as they choose, etc. So that's one side. It's basically prediction feeds where the main user is traders initially. But then where do these predictions come from? Are they any good, right? So the first thing we did actually towards this was make sure that we could get accurate predictions internally. And we got to the point where we got accurate predictions, and we've been trading those against those internally with real money because it's accurate. So we've got decent accuracy ourselves, and we could have sold that ourselves as the Ocean Core team, Ocean Protocol Foundation. But that's a bit centralized-ish, and we don't really want that. We really want to kickstart a data economy. So we looked around and we saw there's different approaches to basically leveraging wisdom of the crowd from an optimization perspective. Most notably, how CowSwap does it, where there's a bunch of different CowSwap solvers that every minute or so there's a bunch of different trades to be matched, orders to be matched in this DEX setup. And these CowSwap solvers, each one runs an optimization to try to maximize the amount of matching, and then spits that back and then does some matching, and the winner wins and they get money. So that's CowSwap. So CowSwap is a very interesting sort of DEX that is sort of solves this coincidence of wants among traders. So trader one wants to trade A for B, trader two B for C, trader C. Trader 3, C for A, B, C. But you can have 100 different trades in this sort of spaghetti mess, and these solvers go and solve that. That's what CowSwap does. I've been a long time fan of it. It's from the Gnosis team. Long time fan of the Gnosis team in general. There's other examples too. Numerai is doing predictions where people submit predictions. In this case, Prediction, the centralized hedge fund, takes those predictions, aggregates them, trade against them, and then shares the proceeds back to the people making the predictions, which I think is really cool. I'm a big fan of Numerai as well. So what we're doing here is people can submit predictions for tokens. So in Numerai, they submit it for stocks in an obfuscated way. In our case, they submit it for a prediction. Will Bitcoin go up? Yes or no, 5 minutes from now. Will ETH go up? Yes or no, 5 minutes from now. They stake against it as well. So they have to put their money where their mouth is. And then Predictor aggregates all those different predictions, weighted by stake, and puts that thing for sale, right? And so the people that are making the predictions, if they're really confident, if they're really good, they'll be staking a lot. If they're not confident, if they're not good, they won't stake. And on average, it's going to be correct, or it should be. And in our results, you don't want to be 50% correct or 49% correct. That's even worse. Or even 50.1 or 51%. Ideally, you're 52% or 60% accurate or whatever. So yeah, you're going to be wrong some of the time, but on average, you make money, right? On average, you're correct enough to make money, accounting for trading fees, etc. And that's exactly the case. In our internal experiments, we have that, and now we have this emerging community that we call predictors. The people that are submitting predictions: will ETH go up 5 minutes from now or not? Will Bitcoin go up 5 minutes or not? And then they get paid based on how much money, how much they've staked, and whether they're accurate enough. So, and they get paid on 5 minute intervals, basically, right? So those are the two overall communities. Basically, there's prediction feeds of ETH. Will Bitcoin go up? Yes or no? ETH, etc. And that prediction feed is populated in a crowdsourced fashion, where these predictors are submitting predictions and staking against it. And then to kickstart this predictor community, we are running one internally from Ocean Core team, maybe even two. And then also we've been collaborating with another team to launch one as well. And of course, it's open to anyone. So once again, we have READMEs, et cetera, for people to take and download this code, fork it, et cetera. So we hope that a whole community will emerge of 10 or 100 or more predictors. And the way that you make money as a predictor is threefold. First of all, if you're a predictor and you're wrong, your stake gets slashed, that particular prediction, and it goes to the others. So the others get, it's a zero sum among those stakes. So the people who are right get that value pro rata to how much they staked. But then also people buying the feeds all the vast majority of the people, the payments to buy the feeds, that goes to the people making predictions. And then a small cut goes to the ocean community. And to buy back and burn ocean and a bit more. So that's the second thing. And the third thing is to kickstart it. We don't know how big the market will be for people buying this, right? Will it be, $10,000 a week worth of sales? Will it be less? Will it be more? We don't know, right? So we decided, let's have an incentive program for this as part of our data forming program. And we are putting in, it's 35,000 ocean a week. So at the time of this recording, that's ocean's at about 40 cents. So it's about 10,000 ocean a week, or $10,000 worth of ocean a week to these feeds. We're launching with 10 feeds. So it's $1,000 per feed per week. So basically, as a predictor, you can make money. If you're accurate, you'll make money from slashes of other predictor stake, from revenue coming from the traders buying, as well as from this Kickstart revenue, basically from incentives. So yeah, we encourage people to come, to play with this thing, to trade against it, hopefully make money, to predict, to become predictors, to hopefully make money too. And we're launching with DeFi tokens. We're starting with 10 tokens, but we're going to expand to this. We're going to be going to top 100 coins. We're going to be going to more exchanges and more timescales as well, not just 5 minutes, but longer. And then stay tuned. Beyond that, we're going to go beyond DeFi as well. So we see that. The idea of prediction feeds, it's a new sort of category. It's sort of like a prediction market every 5 minutes. So call it iterated prediction market, if you will. But it's its own unique beast too, because it's also a data feed. It just happens to be a data feed that's very valuable because it's making a prediction. It's sort of at the tail end of this data supply chain where you can act on it immediately and make money. So, we're quite excited about this. We've been working at it for quite a while in the Ocean Core team. And really happy to be, sharing it.
Very cool. So congratulations on the launch. I know DGens will rejoice at that, especially the go-to-market. I know the team at Outlier will have a lot of fun internally with that. So we'll get some of our own prediction markets going. So we're up on the hour. Very appreciative of your time. But I would be remiss to not kind of close off asking you about your perspective on proof of personhood. So, of course, we have OpenAI posing the problem that advances now are going to put everybody out of work. So we need some form of UBI, universal basic income, to kind of offset that. The antidote is being positioned as WorldCoin, both by Sam Altman, of course. And the core premise to WorldCoin is proof of personhood. Now, you might not necessarily want to go into a critique of WorldCoin, but feel free. But I think more around this premise, the problem and I guess the opportunity of proof of personhood and approaches to solving it.
So I'm going to approach this from an AI perspective. We have one large problem looming in the AI future, and then one crazy, huge, large one looming beyond that. So the large one is that AI could take away all the jobs. And if you disagree, just at least allow for the fact that maybe there's a 10% chance that it could take all the jobs, okay? So even though there's a 10% chance, then we should start to think about what we can do about that, right? That's the nearer term largish problem, and the super large problem is that we get AI superintelligence, and what do we do about that? And there's no economic incentive to slow down AI research, and it's kind of crazy to say we can solve it just by having AI researchers AI doing research to solve it. Like you still need some fundamental solution. So for that, My quick answer there is humans needed a competitive substrate. We need human superintelligence, but that's for another day. But so going then to this nearer term large problem in AI, this risk of AI taking all the jobs, and I actually have seen this as a big risk for years, right? I've been doing AI professionally since the 90s, right? So I've written about this in the past, long before WorldCoin, and thought about it and talked about it with friends and stuff too. To just pause that for a second, if you think about when people work, most people in the world, they don't like their job. So they're working to feed their family or feed themselves and probably their family if they have a family. And maybe 10% of people are getting satisfaction from their job, right? Maybe 20, depending on how you measure, right? But whenever we talk about, UBI and stuff, people always say, yeah, but I need it to feel self-fulfilled and all that, right? Well, that's actually just, 10%, 20% at most. And the thing is, you can imagine if you can do that, even without, working to get paid, right? So the point is, we can take the concept of work and decouple it into two pieces. Getting paid enough to feed your family, and then chasing self-actualization. So I really like the idea of If AI is taking all the jobs, we don't get paid that way, then we should have some sort of safety net, in my view, if we can pay for it economically, if we can pay for it, to meet our basic needs. That's universal basic income: food, clothing, shelter, water. But then why stop there too, right? Why not also pay for healthcare and education, going up Maslow's hierarchy all the way to the top? Self-actualization. So for me, it's USI, universal self-actualization income. And that to me is much more interesting, where every person can chase their dreams, whether it's, writing the great American novel or, playing video games in your mother's basement. Take your pick, right? We shouldn't choose. That's the point of universal, And if you think about like when you watch Star Trek or something like that, they don't actually have to worry about income. They can all chase their own thing, right? So there's conceptions of this out there in sci-fi and otherwise that imagine this, where everyone's chasing their own dream and they don't have to worry about how to feed themselves, and they know that if they work hard, they can have access to opportunities like going to Starfleet Academy or otherwise. So I see, overall, this seems to be the most pragmatic approach to solving the problem of AI taking the jobs, UBI or USI. How do we pay for it? There have been, studies out there in Canada, in Europe, elsewhere on this. It's come out actually looking relatively promising. To me, though, we can also simply hack incentives in AI and blockchain too. Like AI and blockchain are general purpose technologies. They're creating a lot of wealth. So why not redirect the wealth that they're creating back towards helping to pay for UBI and USI? So to me, that's kind of a no-brainer. Like imagine you have a fleet of cars, sort of like Uber, but all of them are self-driving, and not only self-driving but self-owning, right? So they start off self-owning, buying with sort of this mortgage from Daimler or whoever they buy from, and then they run in this Uber-style fleet, fully decentralized, of course, and maybe they pay themselves off after 2 or 3 years, right? After that, all their surplus, but there's some for repairs, of course, but all the surplus would go to USI, and this car isn't so smart that it would, care about saving for chasing its own dreams. It's not that smart. But it's smart enough to send its surplus to humans. And I like that scenario. And you can do that for cars, not just one car, but a whole fleet of cars, and then the roads around and the electric grid and everything around. And it's sort of this new layer of infrastructure for humanity. So we've had this sort of layer 1.0, call it nature 1.0, which is the trees and the sun and oxygen and stuff. Layer 2.0, I've been calling this nature 2.0 for years now, and it's actually this, right, where it's all this extra wealth being generated. It's sort of this layer of silicon and steel that then extends this cradle of civilization for humanity, right? And yeah, to me that's pretty exciting. There's an even better label than nature 2.0. Which is called Sovereign Nature, and there's an initiative around that, SNI, Sovereign Nature Initiative, kicked off by Ed Hesse and others, and I really love the initiative. I think it's great. So they've taken that vision and really ran with it. So going to then proof of personhood and WorldCoin. So to be honest, full kudos for Sam Altman recognizing this in the early days of OpenAI. He got really worried about this. So he went and started WorldCoin soon after OpenAI. Elon, working at OpenAI, got really worried about the second big problem and went off and started Neuralink to help basically, towards human superintelligence, basically, right? They don't talk about that much, but that's, the prime motivation of Neuralink. So kudos to Sam Altman and co. for doing WorldCoin. I think from a marketing perspective, they certainly grabbed the world's attention with these orbs, which immediately repulsed a lot of people. And overall, I think it's actually, really useful that they're trying to solve proof of personhood. Obviously, in blockchain land, we have this idea of a Sybil attack everywhere. So if you have a useful decentralized proof of personhood, then that can be very, very useful, right? WorldCoin itself is fairly centralized, but they've done, from what I can tell in my cursory review, a pretty good job on the privacy, right? Everything they do store centralized right now, but it's all encrypted, and it's just or accessed via zero knowledge proofs, et cetera. So they're doing a pretty good job there. And I was skeptical, and then I was talking with this fellow Remco Blonen, ex-Berliner, who I deeply respect, not only from a technical perspective, but also values perspective. And to be honest, he changed my thinking. Like, he really opened me up saying, just teaching me about what they were up to with WorldCoin. So I'm probably more positively biased than a lot of people in crypto. So thank you, Remco, for opening my eyes more. But also I'm biased because I already believed in the idea of UBI/USI and all this. So yes, there's still centralized aspects. Yes, it happens to originate from Silicon Valley, which a lot of people don't like. What I tell the crypto world, get over it, right? Like, it's a solution, and they're doing a very good go-to-market. So, good for them. And in the end, maybe that'll be the prevailing standard. There's other potential competing standards. We'll see. And overall, it's the sort of thing that could get more fully decentralized over time. And, with the Remco Blonins of the world involved in this, I'm more positive that it will be.
All right. Well, Trent, look, thanks for that. I mean, we've covered so much. I appreciate your time. I know you are, I think you may be even on vacation at the moment in Latvia. So over an hour of your time on vacation is worth its in gold. So, but Trent, it's been great to catch up. Really looking forward to seeing the success of Predictor, continued success of Ocean Protocol. Thanks for coming on.